All right, here's my first attempt at class notes video. When we first started this unit, we went through identifying chemical and physical changes, and this was just the list we brainstormed in class. Then moving forward, we defined chemical change, right? It's the forming of a new substance through a chemical reaction, and this has to happen via the breaking and forming of chemical bonds. We identified evidence we can see, release of energy, production of a new substance, a gas or a solid, a change in color, change in smell, and a few others. We then looked at some examples, right? Some from previous labs we had done, and then some different demos that we did in class, and we worked through these for quite a while, looking at the different necessary parts of a chemical reaction, how we write it out, and then we finally got to what the different kinds of chemical reactions are. This was one of the homework practice that we went over. And then we got to this idea of conservation of mass, right? We learned in physics that matter cannot be created or destroyed. Totally stands here for chemistry, and we use this idea as the foundation for balancing our chemical reactions and making sure that we are not gaining or losing matter on either end of a chemical reaction, because we can't. Yeah, we see that all mass present before a reaction is also present after a reaction. Even if it looks like we lose some, it might have just gone off as a gas and been something else. But if we carefully tracked everything, all the mass should still be there. Then we looked at some examples of some other types of reactions that we hadn't covered before. We got our combustion and our double replacement with our yellow precipitate. And then we got into the details of the types of reactions. We saw that a synthesis reaction is one that results in one product. That's kind of the hallmark of how we could identify a synthesis reaction, by forming only one product. For decomposition, we saw that a decomposition reaction always starts with one reactant only. So that's kind of how you can identify that type. For single replacement, we saw that it is always an element and a compound on both the reactant and product sides, and we can have both cationic or anionic single replacement reactions, depending upon the identity of the element, right? If the element is something that forms a cation, it'll be cationic. If an element forms an anion, then it'll be anionic. Then we got to double replacement, and that's where you have two ionic compounds on both sides of your chemical reaction. And really, it's just a swapping of partners, right? If we looked at the single replacement as, somebody stealing your dance partner at the dance, the double replacement is more like square dancing, where just partners get swapped. So the iron takes the place of the sodium takes the place of the iron in this example. And again, you identify this by seeing two ionic compounds on both sides of that reaction. And then lastly, we looked at combustion reactions, and we saw that it's this kind of organic type compound, carbons, hydrogens, maybe carbon-hydrogen with a little oxygen, and that it always reacts with oxygen gas to form carbon dioxide and water every single time, and you need to know that. Then we got into balancing, right? And we saw, okay, to make conservation of mass stand, now we see that we need to be able to fix the numbers of the different compounds on both sides to get it to all even out. And we saw that we can't mess with the formulas of compounds, because then those would be different substances. We can't simply add elements on either side, because then that changes the reaction. So our only option is to add these coefficients, the whole number in front of the chemical species. And that then dictates how many of each of those there are in that balanced chemical reaction. Then let's see, we just did some practice. We looked at the quiz. This was just today. And in the quiz, we just looked at these are the skills we should have by now, right? We need to be able to identify the type of reaction, what is the evidence of the reaction, and to then go ahead and balance that chemical equation, which does require translating the names of chemical compounds into their balanced formulas. You can't balance a reaction unless you're starting from balanced chemical formulas. Then last thing we learned today was bringing in this idea of predicting products, to where all we should have to give you is the reactants, and you should be able to then identify what is the type of reaction and then make a prediction as to what those products might be. And so we did say that really this works for single and double replacement very well. Synthesis and decomposition, not so much. Those are going to be trickier. We would only have you do the most simple, straightforward, where it was really obvious that that must be what's happening. We would never ask you to do more complex ones of those. And composition, or not composition, I'm sorry, combustion is always going to be that organic compound with oxygen to make CO2 and water. So there's not even any predicting there. It's just remembering what that is. So again, the steps to doing this: first, identify that type of reaction. Do I have two ionic compounds as my reactants? It's a double replacement. Do I have an element and an ionic compound as my reactants? Well, that's a single replacement. Do I have an organic thing and oxygen? Boom, that's a combustion. Okay, so that's where we wanted to focus there. Let me know if this is helpful, and I will try to keep doing it. All right, good luck.